Welcome back to our channel. In today's tutorial, we'll be diving into the fascinating world of object detection using YOLOV8 on a custom dataset. YOLOV8 is a state-of-the-art model that enables us to detect and identify objects within images. So let's get started. Before we begin, let's make sure we have access to a GPU for faster training. We can check this by running the command NVIDIA SMI. If you don't have access to a GPU, don't worry. You can navigate to Runtime, change runtime type, set it to GPU, and then click Save. Let's run the command now. Excellent. Now that we have our GPU set up, let's move on to installing YOLOV8. There are two ways to do this, from the source for development or via pip. Pip method is the recommended method. We'll go with the pip install method for simplicity. After installing YOLOV8, we need to import the necessary libraries. Let's import the required libraries. Ultralytics is the core library we'll be using. Now that we have YOLOV8 installed and ready to go, let's move on to preparing our custom dataset. Building a custom dataset can be a time-consuming process, but luckily, RoboFlow makes it easy. It allows us to collect, label, and export images in the proper format quickly. If you don't know how to prepare a dataset for training YOLOV8 object detection, you can watch my previous tutorial on how to prepare custom data to train YOLOV8 for object detection. The link is given below in the description box. Let's create a directory for our dataset. For this tutorial, we'll download the Insects dataset. This dataset is part of RF100, an Intel-sponsored initiative to create a new object detection benchmark for model generalizability. It contains 995 images with annotations for different types of insects, such as armyworms, blister beetles, red spiders, and more. The annotations are in YOLOV8 format. If you're following along with your own dataset, make sure to place your zip data file in the home directory of the notebook. You can easily upload data to the home directory as you can see. Let's download and unzip the dataset. Great! We now have our custom dataset ready for training. Let's move on to the next step, custom training. Let's run the command below to train YOLOV8 model on the custom dataset. Here we have multiple options for models to fine-tune like YOLOV8 Nano, YOLOV8 Small, YOLOV8 Medium, YOLOV8 Large, YOLOV8 Extra Large model. For this tutorial, I will select YOLOV8 Medium model to fine-tune. This process might take some time, depending on the complexity of the dataset and the number of epochs we set. Let's get back once the training is complete. Great! The model is trained. Now we can check the training results by running these commands. Let's run these commands. Next, the validation step allows us to assess the performance of our trained model. It will provide us with valuable insights into how well our model is detecting objects. Let's run the command. After validation, we can move on to the final step, inference with our custom model. Now comes the exciting part. We will perform inference using our custom model on some test images. This will demonstrate how accurately our model can detect and identify objects in real-world scenarios. Let's take a look at a few examples. Amazing! Our custom YOLOV8 object detection model has successfully identified objects in the test images. This showcases the power and accuracy of YOLOV8 when trained on a custom dataset. But our journey doesn't end here. We also have the option to export our trained model to different formats for further use. We can export the model to any supported format, which can provide significant speed improvements on CPUs or GPUs respectively. The list of supported formats is given here. Exporting our model allows us to leverage its capabilities in various applications and environments. It opens up possibilities for deployment on different platforms and integration into larger systems. And that concludes our tutorial on training YOLOV8 object detection on a custom dataset. We covered all the essential steps, from setting up the environment to preparing the dataset, training the model, performing validation, and finally, conducting inference and exporting the model. I hope you found this tutorial informative and inspiring. If you have any questions or suggestions, please leave them in the comments below. Don't forget to like this video, subscribe to our channel for more exciting tutorials, and hit the notification bell to stay updated. Thank you for watching, and I'll see you in the next video.